And, all right, so the one thing about moving the stars far away that we had, so we put those balls a really long distance away, they were so small, okay? The stars have the size that they have, and you know, when we just went and moved the stars away from us, then they were really little. So now we've solved that problem. Here we have, we're going around the sun, we're on the merry-go-round, and the stars are at the farther away position. And this time, they're big enough that we can actually see them. Now, there was a problem, of course, and that was that the stars were too small. Now, how did we deal with that? Well, as you can see, we have different stars there. Okay, they're not pink anymore, they're orange. And I think it's time that we have a little bit of a discussion about star sizes. Look at these two balls. They appear to the camera to be about the same size. But the problem with apparent size is that when you don't know how far away an object is, you don't know what its true size is. And the true size of these objects depends on their distance. In fact, the ball on the left is much larger than the ball on the right, and it is much further away. So, when you look at an object and you estimate its distance, you're also estimating its size. So when Copernicus says the stars are farther away, well, since they have a given size, they must also be larger. As we can see, let's take a good look up close at these two balls. Here's this one. Much smaller, much larger. Okay, now come on over. So, these are the true sizes of these two balls. So, what happens when Copernicus says that in order to get around the parallax problem, we say that the stars are a really, really long way away? Well, since we've seen that to our eyes, the stars have a given size, if we make the stars farther away, we go from making them like this to making them like this, and in fact to making them huge. Johann Georg Locher did a discussion of this problem and said, look up at the sky. The stars are tiny, but you can measure them. You can figure out, Tycho Brahe figures out, as 10 or 15 stars fit across the surface of the moon if you're looking at it at a star and the moon up in the sky. And Locher says, tiny but measurable. And he says, in the Copernican system, the size of the Earth's orbit has to be immeasurable compared to the overall size of the universe. So Locher says, tiny but measurable is bigger than immeasurably tiny. So every single star in the sky, says Locher, would have to be bigger than the entire orbit of the Earth in the Copernican system. So every last star would be bigger than the Earth's orbit. And a lot of people said they just said this is not cool. They did not accept the Copernican theory because of this. This is Tycho Brahe's big argument. He's the one who first comes up with it. Later, Giovanni Battista Riccioli shows that the same argument still holds with the telescope, that these same sorts of problems with the sizes of stars are still there if you do telescopic observations. They just think that the telescope makes the measurements better, but it doesn't solve the problem. So, this was the size of ball that was used for the parallax when the stars were close. This was when it was far away. Of course, the argument that Locher ends up making is that in the universe, you would need balls the size of that whole merry-go-round back there. you know, the size of the Earth's orbit. That's how big the stars would be. And then you'd have this one little bitty sun in the middle that was in the middle of it all. And so you can see the issue with stars and sizes and parallax.